Okay, so now we're going to give a more complicated example. So we're going to give A unite B star all star B star. So we're going to look at a couple of things. So we want to know how we can connect a star in a branch with a unite, and also how to connect two stars with one another and maintain that the concept of the regular expression still stands in terms of where to accept. So if we have right now B star, the way to represent that is, of course, we've already represented it before. And so it would be, we would have the accept string, which was accept 0 occurrences of B. And then we would have here B and then an accept. And then we would have the loop that allows us to accept more occurrences of B. So we'd have the loop here allows us to accept one to many occurrences of B. And this one, the start state that is also an accept state, allows us to accept no occurrences of B. And then we're going to represent the other side. So this is just me showing you what you need to do in a formal evaluation. So you would have to represent each piece individually. And so this is a representation of A. And so now when we want to connect these together and create A unite B star, so we're going to take each one of the branches and then connect them with a new start state. So we're going to add a start state and then have empty string here, and then we're going to connect each branch that we created before and connect them. And then of course we have the branch where we may accept 0 occurrences of B, and we may accept many occurrences of B, and then we have the empty string here and the empty string here, and also, sorry, the empty string here. So this is A unite B star, which means that if it goes through this branch, right over here, which means that it goes through the branch of B star, it may have no occurrences at all, and so that accept has to stay. And so if it goes through the other branch over here, then it's going to have one occurrence of A, and then it will accept. So now let's go and see how we can have this as a star. So it's going to be A unite B star, and then another star. So we're going to take the same occurrence. Now we said that if we have a star that encloses everything, that means we may have a 0 occurrence of it. So what we're going to do first is we're going to create the accept state at the beginning, so that if we have no occurrences, and then we're just going to take the complexity that we have in the middle here for the star, and we're just going to keep it as is. Okay, so we're going to do that, and we're not going to change anything. So here we're going to do that, and so this is exactly the same as the one on top. Okay, except that we now have this new accept state that accepts 0 things. So now if we reach any point in the accept, we may go back and have more occurrences of this star, which means that for every accept state, it has to loop back to the beginning. So every accept state loops back to the beginning. Every accept state here loops back to the beginning. So for you, you would notice like try to find all the accept states, and then just create a new transition from all of the accept states back to the old start state of the complexity in the middle of the star. So now let's say that I have a star and then I will connect the star to another star. So what happens to the start states in this case? So we're going to use the same one that we have. And here we can look at things as an abstract. So we have this question. So we're going to take the one that we just created as is, which is the beginning, and we're just going to keep it as it is, right? We're not going to change anything. And we're going to see if the concept still holds, right? So we have this, this, and this. And then we have the other branch, the A branch. And then we have here the empty string. And now all of these have to loop back, right? And so all of them loop back. So the same complexity, right? Okay, so now when we look at this question, we know that we may accept 0 occurrences of both because both of them are star. So one of the possibilities is that we have actually nothing. So this is where this accept state comes in, where we have actually nothing. So what if we have one occurrence of the first one? In this case, if it goes inside the occurrence, right, it's going to have to pick one of them. And if it is done with the choice of one of them, it needs to go through any of these accepts, right? If it doesn't go to the second part. And so this is why we need to keep these accepts. That's because it may have an occurrence of the first one and no occurrence of the second one. So that's why we need to maintain all of the accepts here. Okay, so now each one of these accepts would accept the beginning of the part. So let's say that we do have an occurrence of B here. And so if we have an occurrence of B, that means that every one of these accept states has to point, each one of these accept states is going to have to point, right? Like this. And then here, all of them need to point. So these are the accept states. And so we have empty string, and empty string. What are all of these pointing at? All of these are pointing at B star. And so now we're going to draw B star here. Okay, and then here. So we're just going to add B star as is. Okay, and then we're done.